Hi, this is Kurt Grusho with Super Sky, and I just made this video because there's an awful lot to coordinate on this project, and Super Sky is just one part of several window and panel people working for Granite Glass, and you've got the steel, obviously the architects, the structural engineer, and then you got these roofs. There's an awful lot going on, and coordination is obviously the most important thing to get hammered down uh, pretty quickly. So, attached with the link to this video, I'm giving you the model that I made. But that model can't become the basis for everyone's work. Every contractor involved has to take responsibility for their own work, interpret the project documents, do what they need to do to meet their obligations. I'm happy to share what I built for Super Sky's participation, but Super Sky can't take responsibility for the project overall. We want to be a team player and we want to help, but everybody's got to do their part. And hopefully, what I've done will give a little bit of a boost up, and we can all build and get things coordinated so the design comes off as indicated in this picture. It's a pretty nice looking building. I talked last week with some of the architects, and I'd like to now explain what and how I've modeled so you can see what is different, what's the same, just kind of bring you up to speed what I did. It's an awful lot of work. So here's the structural drawing that I was working from. It's a steel pricing set, June 28th, 2019. And if you look, I've gone through it. I think I'll actually send you this set back with the thing, with the model. I've highlighted all the numbers that I used, and then there were a couple here that I circled where I had to fudge them a 16th to make them come out. And I was certain that was rounding, and then when I got a grid layout, that is what happened. So for the most part, I've hit all the numbers, and I've gone page by page, kind of working through it. You'll see little things here like, is this really 16 inches or 12? I'm sure there's an awful lot of detailing to check, and if you just kind of walk through it, none of this is like anybody to change anything. It's me working to build the model. I guess that's the easiest way to put it. This is the little roof we talked about, and there is another roof that's going to come here. We can work those out after we get the rest of this done. I don't think that's going to drive the main structure. Everything should be okay. I skipped over it real quick, but after we talked, Catherine sent me a layout of the plan, and it moved grid 9 1/5/8 of an inch closer to grid 10, I think. And I've made that change to move that post and these beams in my model. More on that as we go through it. These are all different roofs, and I've just highlighted what I modeled. This is the roof by the skylight, and we talked a little bit about web vertical or web tipped. And these beams here were so slight that I made them web vertical because I think that will help other people who have to frame glass into it. I don't actually attach to it with the skylight, and I think web vertical is close enough that that's where you want to be. These at the knee and at the head were supposed to be web vertical, and these were web vertical. All of the beams on the interior would be tipped into the plane, and that's not a very big tip actually. It's a couple degrees. It's not anything real drastic. I did not model any of the diagonal bracing. That doesn't really impact me, and it probably is going to a different spot than I would have picked. The roof slope is 3/12, and you'll see that when we get to the model. This high roof we talked about, and I actually messed it up, but it still did need to change. And I took it 3 on 12 perpendicular to this level beam. That means this beam is level as well, and this guy runs normal. Um, and I think most of them are web vertical. This beam and this one are probably the only ones I turned, just because there's windows framing in underneath most of this. So if you would tip them into the plane of the roof, when your vertical curtain walls come up underneath, you'd have a little angle between the curtain wall and the bottom of the beam. And I thought that might be a problem for people. So better that it's just web vertical with a slope, and that should work out. All of these work points have been adjusted to lie in the 3 on 12 plane, and then I set this 142.1 to be this height, and that's what set this plane right here. Then I even kind of played with the deck and set a level line out here and trimmed off the deck line for you. But what I didn't know how to set out this side, so I just went straight with the 3-inch offset that was pretty standard. So one thing I did, and I apologize, but it did work out. I think this beam should be 140 foot 5 inches elevation, because that works perfectly with the 3 on 12 slope and the 133.11 shown on this plan back here. This number and this number work if this is at 5 inches, not 4.5. I'll show you that in the model as well. So I did not check everything over here with the bracing. That comes out of the model, and I don't need the model, all that stuff. So we'll put that away and start looking at some of the CAD stuff. This is the layout that Catherine sent me, and over here is the layout I created, working from the numbers on the drawings we just went through. All mine are in decimal inches, and you can see, like right here, mine go right to the exact corner, but here the diagonal grid is a little bit off that center, but it's a tiny amount off. And if I just plot mine down as we go through it, you'll see most things are lining up pretty closely. The red one being me, the white one being Catherine's, and they just kind of work through. Over here the walls were coming out pretty close. Just as a way to check it, that's a circle that doesn't even have a dimension in fractions, so everything is tight to where it should be. Over here the elevator seems to be over a bit. Actually it goes farther that way. I did not change my model, so kind of from grid 9 to 10, my concrete and block wall for the elevator shaft is wrong. If I get a chance, I'll go back and fix it, but for now, that wasn't important. So that is just to kind of illustrate how the math did match up. Even over here, it's matching. We just have the little bit of variation there, and that may be an update that I wasn't aware of. So going back to these are work point lines that I put at the top center of steel beams, mostly. The columns are at the centroid, and everything is laid out per the plans one by one, and then until we get to the roof. If it's green on the roof, it's web vertical. If it's red, it's tipped in the plane. And the wireframe obviously gets a little intense to look at. But let's just go to the slope on the roof. And I will show you. So this beam at the top is at that 5-inch elevation. And this sloping one, its work point comes right into that. Each one of them, if you get it just right, you can see the line just poking through the solid. So I want the center there, and then it runs out to the centroid of the column out here in the front. If you look, you'll see that line hitting this one. And if I turn on the vertical steel, these are all shaved off in the plane. So when these beams are put web vertical, there's a little bit of odd alignment. But no matter what you do, some things are going to be different than others. You could take the columns and cut them off per here, to match the sloping beam, but then they would fit funny with here, with the tipped roof beam. And you guys will have to look at that and work on that with the engineer. It's not for Super Sky to say. I like that they're tipped in plane, and I've got them all set up so that they intersect nice. I didn't try to trim anything off for that. Over here with these beams web vertical, they hit the columns nicely. That one comes in, and I worked it off this side. There was a dimension in plan of 4 foot 0 3/8. I projected it up, shot it off at that degree. I think I have them located where you want them to go. It isn't too much. This is where you got the bracing in this wall. So these columns are cut off to the slope so that everything kind of lines up. Now, how the skylight connects to here is going to be complicated. We may have to come back and talk about all these to see what's the best way to make everything work, but it is in a plane so that you can work with it and at least see my opinion of where a good spot to put them would be. And then we had talked about the high roof. Pardon me for a minute. And I did those web vertical. And the columns, again, are sliced off in the plane. So you can see there's a little bit of misalignment because these are web vertical in the white, and the blue is cut off to the plane. But it's very slight. And by making it web vertical, this beam here and this one run parallel. So when you go to fit a window in here, they're just going between parallel surfaces. And if we put some of the steel below, let's just put all the horizontals on. So on this wall out in the front, this beam is web vertical, and so is this one. So the bottom flange here is square to the top flange on this one. And I thought that would be important for the windows, because you're going to have really a window fit between these two beams, fit between here. You're going to have all these little punched window openings that have to go, that the curtain wall will have to connect to. But again, please look it over and see if you agree with what I've done, or if something needs to change, let us know, because it will affect the skylight as well. I put the floor slabs in just to give a reference, for elevation. I didn't worry about it being too accurate over here or on the back side or even at the elevator. I was more interested in the elevation and referencing off that. The foundation wall was in there, but I struggle with foundations a bit. I would not take it too literally, and I put the existing building in very schematic. So that's the model, and then if I put the decking in, now we pretty much have everything on. I will work on some details for the skylight next. Right now I don't have them. I am aware that the deck covers up the two beams the skylight has to connect to. and I'm not sure how to work around that. I do not think we can connect to the deck. The skylight should have a load to transfer to the steel of a couple hundred or a couple thousand pounds, depending. The engineer will have to tell us that. Um, we had talked about adding a tube here. I think that would be a good idea. It allows me to downsize the bars for the skylight, that they fit better on your building, and I can use a little bit different options for how to drain things that I think will help us up here as well. In this window, this is now the controlling span for the verticals. There are two rafters here that are full loaded both halves. I'll reinforce them to make the span. I don't think there's a way to put steel in here that wouldn't just interrupt the window. And we can reinforce the two bars to make them work. The engineer said that would be okay. Everything else works as it is. I don't know if this window, it looks smaller to me than it does on the picture. So I don't know if you want to check the elevation of these 12 by 6 tubes. This one is 57 inches above the steel for this floor, and I think this one was 55 above the floor over here. I'm not sure where those are supposed to be, but that's what was on the drawing, so that's where I put it. You might want to investigate that. The steel is here, and okay, before I get too sidetracked or lost in my thoughts, I cut a section through here just real crudely and through this window, and I have that in the layout tab, and I use that to start roughing out some details. I took the 6-inch bar, I put the vent in it that's supposed to go there. I centered the 6-inch bars on the curb, which is 6 inches wide. There will be a pretty good reaction here because that whole bar is going to be kind of leaning on that. And then I started, there were some curtain wall layouts that were more up to date from the architects, and it was 2 inches, then 2.5, then 2 feet, 2.5. And I used those numbers to work out where my bars would go. These bars are flush glazed, not capped. We should talk about that. If they have to be capped, I would have to use a different system, and I can go back to that. But as a starting point, I put these bars in with flush glazed joints on the vertical. That's probably something we should talk about to make sure that's something we want to do. And I've populated it per the curtain wall drawing all the way up here, and then the structure is off the model, which is off the structural drawings. So the first thing you see is this 5x5 tube is not quite centered in this double bar. I think there's a panel that's going to go in here. I don't know if we want to adjust this 5x5 tube to be centered. I think that would make sense. Be a good adjustment. And then this one comes up. This bar is per the curtain wall. I don't know where the ceiling comes across. I didn't dig into that. But I would guess that this bar should line up with ceiling at this point. This one is just above the slab. If I put a number on there, it's 1 3/4, and then probably another 1 5/16 to the top. There's a vent there, another vent. Here's our added tube, 9 foot 6 3/4 above the top of steel, our floor slab. I'm not sure how I'm going to connect to that yet. With the crossbar right in front, that makes a challenge to do an anchor, and I did this pretty fast, but I think that is the way we would want it to look. If I could offset the tube, that would be great, but I think that's pretty questionable on a curtain wall. So over here on the layout tab, these are main wall vertical details. Here's one with the hatch. By no means is this finished. It's a starting point. You guys have been waiting to see these dimensions. I thought I could give it to you now. I'm going to be adjusting as I go forward but at least you guys have something to work with. This is a standard support. This is about as far back as I can push it. I would rather it was an inch or two more onto the meat of our bar. So I have to look at what we can do for supports, and we'll go back and talk about that in a minute. This is the rafter we'll reinforce on the punched window deal. And that will work. That's all been engineered. These are horizontals. I'll have a welded plate at the end of my verticals to connect to the concrete, and a little crossbar, or a full crossbar, a little bit above that. Here's a full depth crossbar, one with hatch, the header of the hatch. These would be the rafter at the skylight and the crossbar. These will tip a little bit depending when I get into it to look at what we call the cross plane. When you have a bar skewed across a plane, there's a little angle that it tips off the face of the glass. I have to work out what that is. It's only like 2 or 3 degrees. It won't be a big thing. So that's your detail information to kind of look. This is where I spotted to put the frame. The tube barely works. It'd be nice if the tube was a little bigger and maybe closer out to the face of this column. But up here at the floor beam, this is even farther back. I don't know if it's possible to add some lengths of tubing in here so that we could connect to the tube, which is already shop welded to the beam. That would allow me to do the same support as this up here, where nobody can see it, and that would be helpful to have some kind of steel filler in here that we could then attach to. And I think we would want the same filler up here. When we get to it, this wall will terminate, and the skylight will go over it, and there will be a 1-inch gap so that the wall can expand up and down and the skylight can expand this way. They'll need to be separate. They won't be linked together in any way other than flashing and caulk. So go back to the model for a minute, and I think that's most of it. Perhaps we can talk and kind of lock down where we want to go. First thing is know where the structure is, then detail the windows around it. And then there was talk with this roof down here that we left for later, that there's going to be a roof coming off of the face of the wall that covers up the ramp. And I think that roof is going to dictate this one more than the other way around, like we were talking the other day. If there's a sketch that gives the basics of the roof, the pitch, the height of it at some point, I'll be happy to go in and model more of the structure, because that's going to affect that whole front elevation. Right now it's drawn with the panel, but the roof is going to replace the panel, I think. And then there's penetrations through the panels. And then when that gets here, or intersects that little triangular roof, the one coming across the face will dictate the detailing of that. Then we can set the pitch for the roof that goes back through the wall and into the building. Visually, not physically go through. So there's a lot to do. I hope the model helps you get a little bit more progress. I'm sorry it took a while, but it's been a lot of work to do. Thanks, and I look forward to talking to you soon.